Can I threat you?
Belinda, I'm sorry I brought up the whole subject.
Hey guys, welcome back to the Crosley 307T restoration project. I hope to wrap it up in this installment. Since we left off, let's see, I had just about finished the cabinet. I'm going to do a little bit more work on these fancy detail areas and the front edge here. Just about done with that. I'm going to do one final semi-gloss coat over the whole thing, which leaves one problem remaining with the chassis. It has a pretty sharp picture, at least on a little test CRT, but there's a rather annoying hum in the sound, and it does not vary with the volume control. So let's commence to doing some troubleshooting. I hope we can all learn something from the process. So let's see if we can narrow this down a little bit. Here is the audio output stage. Speaker 6K6 audio output, 6AT6 first audio, and volume control. And to the left of that is the 4.5 FM modulated audio stages. I figure the problem's got to be in here, because to the left of it is, well, it's modulated high frequency. This is where we're in the audio range. So we want to narrow this down. An easy way to do that is to ground the input to each stage. So if we ground the center wiper or the grid on the 6AT6 and we hear hum's pretty much guaranteed to be in this area. If we ground the grid on the 6K6 and still hear hum, it's got to be coming through here somehow. Well, geez, I found the problem pretty quick, I think. To replace this 2-section electrolytic. I never connected it. So there's the dual 2.2Ks that are supposed to go to this cap. So yeah, that cap is not in circuit. Just I thought that was probably the one causing the hub, because it goes right to the plate of the audio output tube. So how about we hook up that cap and see if the hum goes away. Yeah, I'd say it's a little bit better. Imagine that, hook up the cap on the audio output stage and the hum and the audio goes away. Not out of the woods though, completely, because it doesn't sound so hot, does it? As I adjust the fine tuning, yeah, it gets better, but there's sort of a couple different peaks and the tone changes as I go through this. There should be one distinct good spot, or at least I'd prefer there was. Like, I don't know where exactly this is the proper spot to put it. So I think we need to peak up the audio. Now there is some buzzing too, but that's the high voltage. In particular, it sounds like it's actually coming from the test CRT, so I'm not too concerned about that until we get a proper 10 BP4 with the grounded Aquadag hooked up. I'm not hearing buzzing coming from out of here. But it does remind me there is one last thing I want to do, which is to get in there and swap out that shorty 25 watt power resistor for the bigger 50 watt variety, because it does get a little bit warmer than I'd like it to, and encaged in this box the ventilation isn't so hot. Maybe that's why they used that very large one to begin with, because they knew the ventilation would be a little bit restricted. So yeah, that's why I didn't put all this back together. So swap that out, hook up a full-size 10 BP4. If this is all quiet, then I think the last thing we need to worry about is going through peaking the sound. So in particular, we have 2 stages of sound IF, and this is the discriminator coil, which I think 2 or maybe all 3 of these have slugs on the opposite side as well that need to be tweaked. Okay, sound alignment. If you ever aligned an FM radio, same idea, just a different carrier frequency. Instead of 10.7, it's 21.25. Now you might have been expecting 4.5, but this is a split carrier set. That's how they did it in the early days, where they had a separate IF for sound versus video. Part of the reason I believe they did that is because the relative strengths of the carriers was different in the early days, so the amplification needs were different. Later they consolidated video and sound into the same IF and picked out sound with a 4.5 megahertz filter. But anyways, That's why you see 21.25 in these stages. Now they give you two different ways of doing it, because back then few repair shops had sweep generators and scopes, but they all had an RF generator and a VTVM. So first section is dealing with the VTVM, second with an FM signal generator and a scope or sweep generator. Not sure why they call it FM signal generator when it says sweep generator frequency right here. Now that's a little bit annoying, because a sweep gen with a center frequency of 21.25 with a narrow sweep, they say 600 kilohertz, is something that a lot of equipment just can't quite handle. So for example, I have this HP3336A synthesized level generator, which is a sweep. Does a very nice job of sweeping. It tops out at 21 megahertz, right where we need to be. Now, video type sweep generators are for doing cable TV systems or video IF. Like this WaveTech can do 1,000 megahertz. Problem with using something like this is the delta F, the sweep width. To get it at as narrow as 600 kilohertz on this is tough to do, because this is made for sweeping cable TV systems. This can sweep from 1 to 1,000 in one go. So I'm not saying you can't do it. I'm saying it's really tough. You have to have the controls that they're really down to their limits. So this, it's kind of too low for this, and it's too high for that. And that's a fixed RF generator, so we can't use any of this stuff. That's why I say it's annoying. And of course, you may have the right type of equipment. I do, but just not out right now. But I do have to do the fixed flavor we can. We can use this HP 8657A RF generator, also the 21.25, and we'll go through it. So for the fixed flavor, it's very similar to an AM radio in that we inject 21.25 where they say, and we adjust this coil for maximum deflection. We adjust this one for a zero reading. We adjust these two for maximum deflection. In other words, we're either adjusting a slug, a powdered iron slug inside a coil for a minimum or a maximum as we go through this. The goofy part is when you get to this stage where you actually want to rotate a slug so that it goes positive and negative, and you want to get it in the zero crossover point. That's where the visual comes in handy, because this is what they call an S-curve. That's what you want the response to look like, but you can get by without it. Now, you may have noticed I'm using the Sam's Photo Effect instructions. The RCA factory service instructions are essentially identical. I'm just using this because I think it's easier to read, and one of the key things you need to do is identify where these coils are. When they say adjust A10, A11, where the heck are they? Well, if you look at the parts layout indicator guide that Sam's Photo Effect provides, it has a photo of the chassis, and they call out where stuff is, whereas the RCA is a little more cryptic, so this is oriented exactly the same way as I have my chassis right now. So let's see, the first thing I want to adjust is A10. Well, let's see if we can find A10 on here. Well, there's A11, so A10 can't be far behind. I bet it's on the other side. Some of these coils, they have adjustments on the other side, primary, secondary. So we have the top as well. And let's see, the sound stuff is over here. So A10's got to be somewhere. There it is, A10, right along this edge. That's this box right here, top of this guy. So the first one we're going to adjust is the top of that, I do believe. So I need to figure out where to hook everything up. So, inject high side to pin 1 of third sound IF V13 low side to chassis. So low side is ground. So we clip the ground output of our RF generator to the chassis. in any convenient spot. And then they say dummy antenna, 5,000 microfarad. Dummy antenna, that means a capacitor in series with the output of your RF generator. You don't take the output of the RF generator and clip it right to the circuit. Put a cap in between that'll block DC and avoid loading down the circuit. So that's 5,000 picofarad, also known as 0.005. We'll use a 0.0047. Close enough. They say to put the receiver on channel 9. I don't know that really makes a whole lot of difference, but we'll do it. And DC probe to point B in series with 1 meg common chassis. So that's your VTVM common to chassis. So the black negative leading to VTM clips to the chassis. And we want a 1 mega ohm resistor in series with our VTVM probe. Even though it's 10 meg input impedance, I want you to add an extra 1 meg to not disturb the circuitry. And it's VTVM in DC mode. And point B, we need to find where point B is. So again, we can look at our schematic, or we may have it on the diagram here. We gotta figure out what point B is. Oh, they do have it labeled. Thank you, Sam's. So it is, it's like the center lug on this coil down here. Now, get your own copy of this. I don't expect you to watch the video and see what I'm pointing to, because even with this in my hand, it's a little hard to figure out. So we want, oh, it's underneath the shield. That's right. So I remember reading in the notes here, you may have noticed shield down here. Sound IF is behind that, but they give you a hole, and they mention on the service info that if you get in there, you should be able to hook your 1 meg resistor onto the lug of that coil that you need to get to. I'll try using an alligator clip and getting in there. If you have to, you can remove the shield. There's some fasteners on the other side to take this off. But yeah, that's right on the other side of that is that coil that we were looking at top side. So a little hard to illuminate, but down in that hole there's a loop of wire. So I took my 1 meg resistor and pinched over the end of it to make a hook, and I put it over there, and then it's holding snug. And notice they put like varnish around that opening that insulates it. So even though the edge of the resistor is touching, the resistor lead is touching the edge there, it is insulated. So we are good, and we have meter deflection. So check this out. I will take my twiddle stick and go to top side of that audio transformer, A10, right? And we're going to rock it. And we're supposed to peak it. So it's actually pretty much on. I'm not expecting any of these to be wildly off, because we do have sound. It's just a little goofy. So peak it. Be right about there. Alright. Move on to the next step. All that work, and we only actually need to go through that hole for peaking one of the coils. Now the next one is the discriminator, where you need to find the 0 crossover point. So I grounded my VTVM input and used the 0 adjust to put the needle right in the middle. Here, I'll show you that. It's this guy. It's a nice thing about VTVM is most have this feature that you can set the 0 so that it's right dead center. Why would you ever want to do that? Well, I'll show you. This up to the last lug on this terminal strip down here, and now we put our adjustment tool into that hole. There's a slug in there, a little hard to find. It's in there, and you adjust this so that it's dead in the middle. And when you rock it to either side, it should swing evenly to either side. That is a center point. So when you're doing the frequency modulation, the frequency shifting one way or the other, That's the deal. When it's dead on 2125, you want it to be zero output. And when the shift frequency shifts one way, it goes negative. Shifts the other way, it goes positive. And that's how you turn FM into audio. So we get to right 1, 0. Alright, I finished going through the alignment instructions, and I tipped the chassis back down, and I removed the horizontal output tube before powering it back up. They actually mentioned that in the service info. So imagine you don't have any of these little test CRTs. I'm sure a lot of service shops didn't back then, not in the really early days. And there's no support for a full-size CRT. You don't want to just have this high voltage dangling in here, you can get shocked. So it is actually fine to pop out the horizontal output tube, which kills any high voltage. So I could actually take this out right now and it wouldn't be a problem. But here's the thing, there's still a buzz. It might not be quite as loud as it was, but it's still there. So we got to figure out where that's coming from. But let's get back to the sound for now. Is it any better? Not really. Not really, unfortunately. There's still kind of 2 points where it's okay. Now, the first few steps in the sound alignment, I didn't change the coils much at all. But the last 2, where you're going further back towards the tuner, I did. And one of them actually had sort of like Loctite on it, probably from when they made the set. Which seemed a little odd, but it's not uncommon when you have the split carriers for them to get out of whack. Anyways, if you find yourself in this situation where you think you did an alignment properly and a problem persists, first thing I suggest you do is question your signal source. So in this case, I'm using my VG91, which recently had some major problems, and I recapped it, replaced some regulators. Maybe it has a problem, and it's putting out bad sound. So, let's get a second opinion. A couple ways I can do that easily. One, I can power this guy back up. And if I put it on 21.25 and enable FM modulation, which this can most certainly do, and probably just lay this near this circuitry, it'll pick it up. And I'm confident this puts out a very nice clean signal. The other thing we can do is hook up a different source altogether, an over-the-air converter box, which will let us see both the signal, the video, and the sound. So let's do that. But the final thing I do want to do is try to do it visually. I've been reading through the instructions, and assuming my HP 8662 will cooperate, we should be able to do that. And if we can, we will be able to see the waveforms in figure 1 and 2, which I would like to see regardless, just for instructional purposes. I haven't tried doing sound alignment with the 8662. In particular, I believe it has 5 programmable markers, which is a real treat. And I can use this nice big WaveTech display. Probably, if not, we'll use a little scope. But first, let's try some different signal sources. Now, on one of the later stages of the sound alignment, one of the injection points is actually a tap on the sound trap up here. So I'm fitting a signal in for my RF generator right there. I tried laying the probe near here, and because of all the shielding, it doesn't pick it up, which is a good thing. So we have 1 kilohertz FM modulation with 21.25. We turn the volume up. That sounds pretty darn good. But here's the thing. Tuner didn't do anything now because we're after the tuner. So it's not quite legitimate. However, what we can do is modulate this as if it was a TV channel. So I need to look up what is the sound carrier for, say, channel 4. And we can put that, I believe, we can go through the antenna terminals and it should work. Could also do 400. It's a little bit of buzz. Just curious, the buzz seems to go away. Go a little bit louder. So it's not perfect. volume control needs some cleaning too. That's odd. There are certain points where it, maybe it's because it's a linear, not a log. Maybe it's a linear taper, not a logarithmic taper volume control. So it doesn't seem to increase in volume linear at all. Alright, let's try going through the antenna terminals. Alright, well, according to this website, channel 4 audio carrier 71.75 megahertz. So I dialed my generator into 71.75, and now I'm going in through the antenna terminals. And there's our tone. What's fine tuning? It's sloppy. We have double peaks. I think that's a pretty good indication. There's a problem. So let us try to do the visual sound alignment. Okay. First off, I have to say, what a treat, what a luxury it is to have a device like this Hewlett-Packard 8662A. I'm sure service techs back in the day would have died to have, would have loved to have had a device like this. It's taken me a little while to muddle my way through it because I haven't quite used it like this before. So, this is a multi-purpose RF generator. You can do all kinds of fun, interesting, cool things. What we're using it for is a sleep generator. And what's really neat is you can dial in the start and the stop frequency to great precision. So, service info says center frequency should be 21.25 and do a 600 kilohertz sweep width. So I did 21.25 plus minus 0.6 megahertz, which gives us 20.65 and 21.85. So start stop frequency means the RF oscillator is going back and forth between those two frequencies. Now this has 5 programmable markers. Right now I just have one set at 21.25. And for the sweep speed, you can select steps, 100 steps, 1,000 steps. This thing at its heart has some digital circuitry. So when you do a sweep, it's not continuous. There are steps to it, so that controls how many steps, and this controls how fast it sweeps. If you sweep too fast, you can distort your response curve. And here's a control panel for dialing in the numbers, the frequencies, and the output level. We can vary that with buttons or a knob. I go into amplitude mode. Alright. So the output of this is going into the set, just like I had the fixed generator going. And I've got my probe at that point where we should be seeing the S-curve. This guy. Well, that's what I have on the scope. I decided to go with my 2465 because the WaveTech does not have a high impedance input. So, it's not quite right. It should be more symmetrical. And I'm not seeing my marker. I'm not sure if I have to hook up the modulation intensity to the scope or if I don't have something configured quite right. The marker should be right in the middle. So that's one nice thing too. If it's a very linear sweep generator and set it up right, I can just go by the divisions on the scope face to know what the frequency is. So the crossover point, well, first off, let's flip this to ground to make sure we're yes. You want to make sure you got your ground reference right in the middle. DC mode. So our crossover point, the 0 point looks like it is correct. Which means using the VTVM and whatnot did work correctly. But it's not as symmetrical as it could be. But I'm not seeing anything jumping out at me as a big problem right here. So we will continue. The other waveforms we want to care about will be the passband, where we check the response of the stages. So let me see if I can get the marker working correctly. That will help us out, but otherwise I'll just have to keep it centered properly so we know 21.25 is right in the middle. Yes, indeed, I had to hook up the Z-axis modulation as an output on the back of the 8662 and an input on the scope. So those bright dots are my markers. The one in the middle is 21.25, and then I have one 500 kilohertz on either side of it, and obviously it's not very symmetrical. So that is one thing we want to deal with. I believe that is our first thing. So adjust A10 and A11 for maximum amplitude of peaks and straightness of diagonal line with marker at the center of the line. So, alrighty. I want to try playing with the sweep time as well and see what the response goes. So I just slowed it down even more. Doesn't seem to be affecting it really. So I think we're okay with that. And here is going with 1,000 steps. So this is the most accurate and slowest I can sweep it, but it's a little irritating to try to work with. So we'll go with this. I think we're okay there. Just playing with some other settings here. But yeah, I think we'll stick with that. Alrighty, let me grab my twiddle stick and see what we can do. So A10, A11, that is the big guy we started with. So let's start with A10. And now we can see in pretty pictures what tweaking that does. Oh yeah, boy, that has a big effect, doesn't it? Ooh. So here, my friends, you can see the difference between doing visual swept alignment and fixed frequency VTVM. When you fixed frequency VTVM, you can only see like a slice here. You can only see the response at a particular frequency. When you do this, you can see the whole shebang. Alright, so we want equal amplitude, which looks pretty darn good right there. So A10 really seems to have been the key to doing that. Let's play with A11 just to see what effect that has, but that seems to have made it a heck of a lot better, just with a slight tweak. And by the way, I turned it like 10 degrees in rotation. That's how sensitive these coils are. That's why just doing it blindly is it's folly. You're really unlikely to get it better just trying to do it by ear. Now this one I'm trying to do is the one that's inside that hole, but here I finally got to it. So that one seemed to have been... So this is the one I adjusted for the zero crossing point with the VTVM, and it seemed like that one was fine the way it was. Right about there. It's slightly off. It's not easy to get the tool inside this hole and mesh with that adjustment shaft. Trying to get it right on where it crosses the axis line. That's pretty darn good. Alright, so doing that made things a lot better, and now let's go through the rest of it and check the actual bandwidth. Okay, now we're getting into some problems here. This is supposed to look like that. We are not doing so good. So the peak should be at 21, well, it shouldn't even be a peak. There should be a trough centered around 21.25. And we're off frequency, and it's not quite as wide and as flat as you'd like it to be. So it's not like AM radio where you want to peak it on one frequency. It's frequency modulated, so you want to have a little bit of a flat, wide response. So what do we need to do to fix that? A12 and A13 adjust for maximum amplitude and symmetry per figure 2. Now, I also want to point something out. They tell you to use a 33K resistor between your scope probe and the set. Check out what happens if I don't use that 33K decoupling resistor. That. It's crazy. It's oscillating or something. It's doing something crazy. So that is why. When they say to use a dummy antenna, a resistor in series with the lead, there's a reason for that. That's why you need that resistor. It was 1 meg before, now it's 33K with the scope. So even though this scope is high impedance, 10 meg, low capacitance, it still messes things up. Alright, I identified A12 and A13, and check this out. Again, it's super sensitive. Me just going near it is starting to affect it a little bit. And if I need my tool, engage with the shaft. So we want that to be on the bottom, but it's not a wide bandwidth too. So let's see. Adjusting the other side helps out. Now, I still have some more to do after this, so at least we want to get this centered on the right frequency. Yeah, it's kind of doing the same thing. It's a shame they don't tell you how wide that should be. It says maximum amplitude and maximum symmetry, so I think that's what we have. Popped open the high voltage box again and swapped out that shorty for the full length 50 watt power resistor. I'll button it all back up, and then I'm going to do some cleaning in this area. Now I think it's time to pull out the full-size 10-inch picture tube that actually goes with this set and give it a whirl. Let's see how it plays with the full-size picture tube now. Fantastic. I don't have to touch the horizontal or vertical hold. Locks right in. The great thing about these early RCA sets, for all those extra caps and extra tubes, what thing it really gets you is a rock solid raster. The rectangular area here. There's no bending, there's no twisting, there's no jitters. It is a rectangle. And with that wide bandwidth, we have a really nice picture. For the sound,
some newsworthy events on assignment. Now in connection with your testimony,
it's okay. It's not outstanding. You do have to play a little bit with the fine tuning and find the best spot for the sound. Contrast has some effect on it. Contrast is a very critical setting on these sets. I'm barely moving it, it's having a huge effect. But when you get everything dialed in right, they play really well. The buzzing. There is a slight buzzing. I have to remind myself. I have my head less than 2 feet from the set outside of the cabinet. When it's in the cabinet, everything's tightened down. You're going to be watching it from back here with the volume up. I really don't think it's going to be an issue. So, what's left? Well, I'm going to let this play for a few hours. This is a very large, heavy chassis. The cabinet is rather heavy. I don't want to have to keep swapping these in and out like I did with another RCA recently. So I want to run this for a few hours on the bench, make sure everything is working as well as I can make it, and then we'll put it all back together. I moved the Crosley up into, well, the room I'm using to hold all these sets one by one as they are finished until they get picked up. Chassis has been reinstalled in the cabinet, just put in the picture tube, and just like an RCA 721 I finished recently, not much hold the picture tube in. You insert it from the front. There are 4 little adjustable pads that support the weight, but this can just pop right out right now. It's the face plate that actually holds it in place. They ship them without picture tubes. So this goes in like that, and it's secured to the front, and that pushes against the face plate. I still need to reinsert the safety glass and rubber gasket. If you recall, that was held in with staples. So I'm going to Have to rig up some kind of fasteners on that. And here's a look at the cabinet. Semi-gloss on the bulk of it, but I did use gloss on these accents. Remember, I retained the original finish down in this area, and these look so neat. I decided to just use a little bit of gloss on that. And very happy overall with the way this came out. I wasn't expecting to refinish it, but in the end, I'm glad I did. Hey, something else I want to mention. When you have issues with sound, I've tripped myself up on this time again. And you think, it's not that weak, it's not that great. Check your converter box if you're using one, because they have their own volume control. Make sure it's up all the way. We've got volume for days now. Alright, so one last thing. Here, let me put this back on. You notice a little dot there, one there, smaller one there. Those are bubbles in the glass, another one there. And back when they made these picture tubes, this Donna TV is really expensive and hard to make, and that was acceptable. So you just have to live with it. Bubbles in the face of the glass.
You wouldn't press charges if I'd let him use the story as it turned out.
Got the set all back together, reinstalled the front cover, the safety glass, and all that good stuff. Got the channel plate back on, the two knobs. So I've mentioned a few times, the hunt is on for these knobs. If anybody has any spare Crosley knobs that look like that, I'd very much be interested. So that is going to be that. Did not intend to refinish this cabinet, but it was good to get back into the game, and it encouraged me to do some other refinishing projects if you've been watching my other videos. So, hope you guys enjoyed this rather intense project of restoring a Crosley 307TA.
Absorbing Pro. Pain
Thanks for watching.
Your passions. It's the only solution with 2 max strength and